All right, so we found the area, a of x, but I think we need to simplify this a little bit. I will simplify this a little bit because I noticed there are two like terms, this one and that one. Let me combine them, and then we'll take the derivative of that, okay? All right, adding the fractions, 1 over 4 pi plus 1 over 16. I can write these as 16 over pi. Make these to be their 16 over pi to be their common denominator. The first fraction, I need to multiply 4 to the numerator and the denominator. So 4 over 16 pi and plus pi over 16 pi. So if I combine them, I will get 4 plus pi over 16 pi. Okay, so area, the combined area is 4 plus pi over 16 pi x squared minus 35 over 4x plus 1225 over 4. They want to find either the surface area, well, they want to find the x value that will minimize the combined area or maximize the combined area. So it makes sense to take the derivative of that area function so that we can critical value, because critical values are where the minimum or maximum may happen. But also, do remember, we do have a range here. X can range from anything from 0 to 70, right? X can't be longer than 70 because 70 unit is all we have. But if we set x to be 0, let's talk about those two cases. X equals 0 implies that we're not going to make any circle, no circle. Just square, right? Or in the other extreme, x can be equal to 70, right? If we use the entire piece to make a circle, then we're going to have only circle. We're only going to have a circle, but we're not going to have no square. So these two are the extremes, right? That's how small the smallest x value can be. X can be 0 or x can be all the way up to 70. But we're going to have a critical value in between 0 and 70 that may have a local maximum or, absolute maximum or minimum. So remember, the 0 and 70 are the endpoints that we're going to test here. But go all the way down, all the way down. Let's take the derivative of this so that we can find the critical values. So let's find a prime of x. Using the power rule, I'll have 2 brought in front. 4 plus pi over 16 pi is just a constant, but x will now have a new exponent of just 1, x to the first power, right? Minus 35 over 4, no more x, and derivative of a constant is just 0. Now, it looks kind of fancy. I can try to simplify this a little bit. I can divide this 2 over 16. I can change that to what? 4 plus pi over 8 pi. That's the slope. Minus 35 over 4. You notice this just looks confusing, but it's just a linear function, and a linear function is always defined everywhere, so we don't have to worry about the places where the derivative does not exist. At least we can set this equal to 0 and find the critical value that way. So set this derivative equal to 0, and let's solve for x. First, add 35 over 4 to both sides. I'll get 35 over 4 equals 4 plus, I'm just trying my best not to round my answer in the middle of a problem. So I gotta just keep this 4 plus pi over 8 pi everywhere, every step I go. But now, let's multiply by the reciprocal of that. 8 pi over 4 plus pi on both sides. 8 pi over 4 plus pi. So that we get to say, hey, finally we solve for x. x is going to be, I can simplify this 8 and 4. So I'll get 2 pi times 35, and 2 pi times 35 is 70 pi over 4 plus pi. Yay, we found that one critical value. I can find the second derivative, plug it in to see if it's local minimum or maximum. But instead of the second derivative test, let's use the endpoint. Let's actually plug them all into the area function and see which one comes out to be the greatest and which one comes out to be the smallest, okay? Real quick, let me go borrow that area function. The combined area was this. I'm going to borrow this guy, but I'll put him back later. Oh, I don't want that circle. I just want to take the area function. You know what we're going to do is we're going to plug in our critical value and 2 endpoints into this area function and see which one gives us the maximum value and which one gives us the minimum value. Ready? Remember the 2 endpoints. We had a of 0 because x could have been 0. We also had the second case, x could have been 70. Those are the endpoints. But the very last one that we better check is that one critical value that we just found, 70 pi over 4 plus pi. What we're going to do is we're going to find the area, if x is 0, 70, or 70 pi over 4 plus pi, and see which one comes out to be the greatest or the smallest. Now, the first one is the easiest. I plug in 0 here, 0 here. The area, surface area, comes out to be 1225 over 4. Now, to make the comparison easy, let me convert this into decimal. 1225 divided by 4 is 306.25 units squared. Now, let's see. Remember, what does it mean x equals 0? What does it mean x equals 0? When x equals 0, then we have no circle. We just have square. I'm going to actually find the area of the square and see if that's true. Okay, no circle, just square. So if we make the entire 70 unit to make a square, what kind of square are we looking at? That square will have a side length of 70 over 4, right? And the area of that square will be 70 over 4 squared. So that's 4,900 divided by 16. And wasn't that the fraction that we reduced to get 1225 over 4? I believe so, but let me just double check. How about we type in 70 over 4 squared, and that area in decimal is exactly 306.25 units squared. So it matched, we're good with a of 0. Gotta find the other ones to actually make a comparison. So let's see. How about we plug in 70 into the function this time? So that will be 4 plus pi over 16 pi times 70 squared minus 35 over 4 times 70 plus 1225 over 4. Now, you know what we're about to find, right? We're about to find an area of a circle whose circumference is 70. So after doing this, we can also find the area of the circle and compare that. They better be exactly the same. But I am typing in this into my calculator to get the decimal value real quick, okay? 4 plus pi, 16 pi times 70 squared minus 35 over 4 times 70 plus 1225 over 4. And that gave me 389.93 square units. I'm going to check this. So imagine having a circle only whose radius is, now I forgot what was the radius in terms of x. Let me go up and find that. Area radius was x over 2 pi. X over 2 pi, guys. So write that down, x over 2 pi. And if x is 70, this will be 70 over 2 pi. So the radius is 35 over pi. Let's find the area if radius is 35 over pi. Area is pi times r squared. So radius, area is pi times 35 squared over pi squared. That's going to be 35 squared divided by pi. What's that going to be? I'm typing that into my calculator, and I am hoping that this comes out to be 389.93, and it did. So one thing we know, we got that good area function. So those two values I will compare. That's the first endpoint. That's the second endpoint's output value. But we do have a critical value that we want to test, right? So let's test that very last one. So this is the very last one that we just need to test. Let me minimize some of these things because these were just me doing some extra work to double check my answers. So I'm just going to minimize these ones a little bit, as they're not really the... How do I minimize this? Okay, but now let's find the output value when x is 70 pi over 4 plus pi. Plug in that into your x. Hopefully, because I mean, I did all that work. I want this to be at least a minimum or maximum something. Squared minus 35 over 4 times 70 pi over 4 plus pi. And then I just need to add the constant 1225 over 4 to that. And what's that going to be approximately? Let's find out. I'm typing this into my calculator because I want to find the decimal value. Guys, I'm typing. I'm still here. Do I regret putting this problem? No, it's okay. We're having a great time. All right, I'm finally adding the constant, the 1225 over 4. When I type this in, this is what I got, 171.53 units. Guys, if I'm wrong, you double check by typing this into your calculator and let me know. But I got 3 numbers, and what I like is that this is the minimum. This is the smallest, right? In order for me to minimize, I better use my critical value to be the x value. What's the maximum? If you want to maximize the surface, the combined area, guess what? X has to be 70. That means you're not allowed to have a square. You just make that circle. So got all my values right here. I'm going to go ahead and take a quick picture of it so that I can go up and fill out these answers. We're ready to fill in the final answers. So to minimize the combined area, remember the x had to be 70 pi over 4 plus pi, right? And finally, let's give them the answer rounded to the nearest thousandth. What is 70 pi divided by 4 plus pi? That is approximately 30.793. So this much should be used to make the circle, and the other amount, which will just be 70 minus 30.793. And if I do that subtraction, I got that 39.207 unit must be used for the square, because those values will give us the smallest combined area. And what about for maximizing? Remember, the biggest combined area happened when x was 70. So use the wire, cut the wire so that entire 70, well, don't even cut it. Just make the circle using the entire 70 unit and use nothing for the square. So very interesting problem. But if I put this on your exam too, I may have to give you extra hour or 45 minutes to complete this one problem. But how beautiful, huh? But I decided, guys, I don't think I will give you something like this on your exam too. I will keep it to either number 1 or number 2, open top or closed top, if I try to be a little fun. But I'll give you something like example number 1 or example number 2 on your take-home exam too. Now, but if you feel very passionate about these optimization application problems and want to do more, you let me know, okay? All right, I'll wait for your email today and Wednesday to see if you have any questions on the practice test. But our plan is to, well, my plan is to send you your exam at 9 a.m. so that if you want to start 30 minutes early, that's okay. But